first session? Are you Dwayne's mama?
Yeah.
I love Dwayne. He's got so much personality. Well, hopefully you'll learn something in this session. We're going to talk to you about math. And this is math night, and I'm sure they mentioned you next Thursday is ELA night. But the statement I heard from a parent today was, why can't we do it the way we used to do it? And I think that's the sentiment across the board. This new math is coming home, and it's like what to do. There's no textbooks. Parents are frustrated. Students are frustrated. Teachers, believe it or not, are frustrated. But believe it or not, we do have your kids' best interest at heart. And we really want them, instead of, I think we kind of got taught procedural, step 1, step 2, step 3. We want them to understand why it is what it is. And then we'll give them step 1, step 2, step 3. So thank you guys for your patience. We're going to get started here. A closer look at adding and subtracting fractions. This is what we're currently on right now, and hopefully maybe by the end of next week we'll kind of be bringing it to a close. But this is one of the standards, Common Core standards, because that's the new thing right now. But this is the standard that addresses adding and subtracting fractions. And just notice the highlighted areas. They want students to be able to use equivalent fractions as a strategy to add and subtract fractions, which is one reason we have been teaching them, just from the beginning, multiply the denominator to keep moving. They can work up to that, but that's why we kind of take baby steps. They have to add and subtract fractions through word problems, which you've probably been seeing on those tests and things. Visual fraction models. The kids will tell you they've been working with fraction tiles. Equations, benchmark fractions, and all that is 0, half, and 1 whole. Because every child can picture what 0 is, every child can picture what a half is, and every child can picture what a whole is. So if we can teach them where those fractions land, at least they can figure my answer should be close to nothing, close to half, or close to a whole. And number sense. Ms. Harris?
Okay. These are just 3 different things that we'll go over right now. Why use multiple representation? That means many ways to represent fractions, or any other thing we may be working on. For teaching addition and subtraction of fractions. Well, first of all, we want to build an understanding of numbers, make a lot of sense, wonder sense, by using a range of different strategies. Representations increase the level of engagement and the level of motivations of your kids and our students. And also to do well in life, and the pass test, of course, at the end of the year, and graduate from high school, college, and support their parents' retirement. All right, and actually, we're in the process, all the math teachers are doing this right now with fraction, and this at the top says multiple representations, and this is my problem, 3, 6 plus 2, 6. And you'll see that the same number here, we're able to add it, and all they had to do was they had to make a word problem out of it using the particular problem. Draw a picture of it, 3, 6 plus 2, 6. Then actually work it out using the algorithm, and that's the way you work the problems out once you've got the concept down. And verbal description, I know that, why did I do it the way I did? Of course, my denominators are the same. I add the tops, and they were trying to explain it that way. They were exactly right.
So tonight our focus is going to be on using equivalent fractions to add and subtract fractions, the concept of addition, which is to add fractions with like and unlike denominators, and the concept of subtraction, which is to subtract fractions with like and unlike denominators, which is the very things your child has been working on in math class. So let's start with equivalent fractions. When I was in school, I was told you multiply the top and the bottom by the same number and it's equivalent. I could make you 1,000,000 equivalent fractions, but I didn't really understand what it was they were asking me to do. So if you look at this first one, everybody knows 2/3, which is our fraction up there. It's 3 pieces, 2 of them are shaded. And what equivalent fractions are is they represent the same amount divided into a different, it's the same amount divided into a different number of pieces. So I'm going to take this 2/3 and divide it into twice as many pieces, or 2 times as many pieces. Has the amount shaded changed? No, but now 2/3 has become 6 sections, 4 of them are shaded. Okay? Sometimes with students, if they don't have this practice, it's like the fraction's gotten bigger. No, it's more pieces, but the amount has not changed. So I might take 2/3 and I might want to make it into 3 times as many pieces. And we're just partitioning it off. Now I have 9 sections, 6 of them are shaded. So an equivalent fraction for 2/3 is 4/6, 6/9. Same thing with this one. We're going to make it into 4 times as many pieces. And that gives me 8/12. So now when your child does get to the point where they just multiply the top times the bottom, they know why. They understand that it's all the same thing, the fraction's not getting larger, it's just more pieces. And with each change, more pieces, but fewer pieces, or smaller pieces.
All right, and I'm just going to show it to you a different way. Consider the fraction 5/5. All right, so I have 5 pieces and 1 is shaded, and I'm going to double it, and I've got 2 shaded and 10 pieces. All right, now I'm going to divide it into 3 parts. So now I've got 3 shaded and a total of 15. Now I'm going to do it 4. Miss Gainey's actually doing that for me.
It takes me a little while to get these
Yeah, I was
things.
enjoying the magic concept.
And now I've got 4 shaded pieces, which is equivalent to 4/20. And they can actually count them out and see that all 4 of those fractions are equal.
So with that knowledge, we can take it over to addition. So what is the concept of addition? Addition, which is something you learn way back in kindergarten, we love to add because it's pretty simple, but it's bringing like things together. So if I have 4 pennies and you have 5 dimes, how much do we have in all? Even though we know that that's 54 cents, we still had to put it on like terms, which is cents. Or we can make it all pennies and it's on like terms, which is pennies. But there's no way to add pennies and dimes. You have to make them something in common. So that's what we're trying to get our children to understand. So I have 4 dimes, you have 5 dimes. How much do we have in all? These things are like, therefore we can add them. 9 dimes, because they're on the same. I like to tell my kids, let's get on the same field. If I'm at Arrowhead, I can't watch a game that's on 3 different fields. But when all the students are on the same field and are playing a game, it's a lot easier. So that's what, whenever you hear or see them making those equivalent fractions or counting up, they're trying to get those fractions on the same playing field. So in addition of fractions, in fractions we can only combine pieces of the same size. In other words, the denominators must be the same. And I cannot tell you how many times those kids are so tempted to just add across the top, add across the bottom, and move on. It will never, ever, ever be correct if you do it that way. So an example, and it's already in like terms because this circle's divided into 8 pieces, this circle's divided into 8 pieces. So now I can combine this 1/8 with these 3/8, and that's going to give me 4/8. And 4/8 is equivalent to 1/2, because you see that half the circle is shaded. And the 8s never changed. It's just like saying 1 cat plus 3 cats is 4 cats. That never changed. We just worked with those numerators. 1 plus 3 is 4. More examples. 2/5 plus 1/5 is 3/5. 6/10 plus 7/10 is 13/10. And now we're trying to teach them to open up their improper eye. When you notice that improper fraction, be able to go both ways. Improper to mixed and mixed to improper. And another one, 6/15 plus 8/15, 14/15. So here is an example with unlike denominators. Miss Miller ate half of a candy bar. And if you're in my class, your child's in my class, that does not come as a surprise. Miss Harris ate 3/8 of the same candy bar. Using a model, show how much they ate altogether. So if you got homework sent home last week and there were fraction bars, it's because of those multiple representations that Miss Harris talked about. They can see it any way on the test. They might see fraction bars, they might have a word problem, it might just be a straight out algorithm. So we try to show them all different ways. And I always tell my kids, compare it to 1 whole. That way, this represents 1 whole candy bar. Miss Miller ate half of the candy bar, and they can really see. I can ask them questions. Did I eat the whole thing? And they can say, Miss Harris ate 3/8. And since it says all together, we want them to put those pieces all together. Now, right now, they're not on the same playing field. We can't combine halves and eighths, and Tony's over here just ready for action. Tony, what do we do first? Count up. So we're going to take that 1/2 and count up to see if we can find, we're going to make equivalent fractions. So I know if I count up, 2/4 is equivalent, 3/6 is equivalent, 4/8 is equivalent. And I like to tell my kids, stop after about 3 to see if you can find a match. You don't have to go on and on and on. And then I'm going to look at my 3/8. And I could actually stop right there because I notice 4/8 and 3/8 are the same thing. So my 3/8 can stay the same. And my 1/2, I'm going to turn it into 4/8. Because equivalent tells me it's the same thing, just different size pieces. So now they're on the same playing field. My 4/8 plus Miss Harris's 3/8 is 7/8. And that's how we have them do it, because they're not going to always have fraction tiles. In Walmart, if they're needing to add something, they can't pull out their bag of fraction tiles, but they can make 2 equivalent fractions, add them together, and move on. Tony, does that fraction need to be simplified? The answer is 7/8. No, how do you know that? Back-to-back numbers, 7. So we've been talking about that too, how to recognize when a fraction is already in simplest form. Another example, Raymond watched a beetle on the sidewalk. It crawled 1/3 of a yard, then rested for a bit, then crawled 1/4 of a yard farther. How far did the beetle crawl in all? So, my 1 whole represents 1 yard, because that's what the story's about. The first time, he walked 1/3. And we're teaching our children, if you ever hear unit fraction, that's where the 1 is the numerator, because you can't take it any smaller. That's as far as I can go. And after the 1/3, then he walked 1/4. Well, it's clear that they're not on the same playing field, so I'm going to have to make equivalent fractions. So for 1/3, I can count it up. 2/6, same thing. 3/9, 4/12. And I'm going to make equivalent fractions for 1/4. Well, there's not a match yet, so I'll make another one. 2/8, still not a match. 3/12, I can stop because here we are. I can turn 1/3 into 4/12. And I can turn 1/4 into 3/12. They might could have done a better job than looking at it. We did. And now it's super easy. All I have to do is count how many 12ths do I have?
7/12.
7/12, because 4/12 plus 3/12 is 7/12. So they've seen it in a word problem. They've seen it with fraction tiles, and they've seen it actually working it out with algebra.
All right. Okay, so here we are with subtraction of fractions, which we just did addition. Subtraction means taking objects away. So with fractions, we can only take away pieces of the same size. In other words, the denominators must be the same. Like, I cannot compare apples to oranges, they got to be fruit. All right, so an example would be 11/12 minus 3/12, and I have equal denominators there, 12 and 12. So this means to take away. So actually my pictorial model is showing 11 out of 12 shaded, and Miss Gainey will take 3 away. And now you can see that there are only 8 pieces left. Therefore, 11/12 minus 3/12 is 11 minus 3, which gives us 8/12, and it's equal to an equivalent fraction of 2/3. All right, fraction steps for success. Know the fraction rules and how to apply them. Show your work and write out each step, and that goes with those multiple representations that you could see them in any form, shape, or size. Check your work for errors or careless mistakes. And Miss Miller, we're going to show everybody how we can play this game, and she's going to explain that to you.
And you could probably turn it into a game, but if you want more practice, and your child is like my child, when you pull out pencil and paper, that equals work. But sometimes you can pull out dice, and it turns into a whole new thing. And you can call it a game, and they're willing to cooperate and work with you. So fraction practice. Here's a simple activity your child and you can play at home to practice adding fractions. All you need are 2 dice. You can go to Dollar Tree, and get a bag, several of them for $1. Each player rolls their die twice to create a fraction. So you have a die, Ms. Harris, and we'll model it for you, would have a die, and I would have a die, and I'd roll it 2 times. My small number is going to be my numerator, my large number is going to be my denominator. So I'm making my fraction at the same time she's making her fraction. Chances are it's not going to be the same denominator, and that's what you want them exercising with and practicing, how to add and subtract fractions with different denominators. Both players add both of the fractions together by creating equivalent fractions. That's where you saw where I counted it up. Finding a common denominator. Where's that match? Okay? And then adding them or subtracting. If you do subtraction, just make sure that the greater fraction is on top. Yeah. We talk about that a lot.
Right.
And a good way of doing that is with those benchmark fractions. If you say, I don't know how to tell fractions apart, which one's greater, which one's larger, you just ask yourself, is it closer to 0, half, or whole? Okay? And your students, your child should have several different methods of comparing fractions. So we're going to model it for you.
You want me to go up here?
We got it.
Oh, good, I like that.
All right. And we're going to roll here, and we'll let you know what our fractions are.
All right. I got it.
2. Oh, same one.
We both got 2, you got 3 again. All right, I got 2.
Okay. So that would be, mine would be 2/5. You roll one more time. 2/5. And that's okay, because that one's easy. 2/5 plus 2/5 is what, 5th graders? 4/5. Good job. Because remember, those denominators have to stay the same. So let's see if we can get them.
Yeah.
I have a 3. Just tell us what you have.
6, 4, and a 3.
Okay, so
Mine's
you,
3, 6.
and mine is 3/4. So, and I always tell my children, write them up and down like that. That gives you room to work. They love to write them beside each other, but you don't really have a lot of space to make those equivalent fractions. So what I would do, you're 3/6, so I'm going to let you create your equivalent fractions, and parents, get your children to do as much of the work as possible. You know, keep check and make sure they're doing it correctly, but you want that practice. And you just saw what Ms. Harris did took 5 seconds.
Well,
And there's her equivalent fractions. Did that take long at all? No. She knew that she could count by 3s, the multiples of 3, 3, 6, 9, 12. She could count by 6, 6, 12, 18, 24. And what she did was 6/12 is 2 times as many pieces as 3/6, still the same size. 9/18 is 3 times as many pieces as 3/6, still the same amount, nothing's changed, just something different to work with. So now I'm going to count mine up. And that took about 5 seconds. And there's mine. You can see it. And about the same deal. So I'm looking for a common denominator. Does anybody know what it is? 12. And be careful. Sometimes they tend to look at the numerators. They really, when you're doing this, they really have to write neat. You don't want them all jammed up and then they're circling the wrong number. So make sure there's some space in there. So this puts us on the same playing field. 6/12 plus 9/12 is what, 5th graders?
15/12.
15/12. Now, what do we recognize about that 15/12? It's improper. Now, 15/12 is correct all day long. But we're trying to get them again to open up their eyes and realize, there's something different. I can do a little bit more with that. Got to do surgery on it. Yeah, I have some weird terminology. But now, in a good way, because I know y'all were taught just like I was, knock it over and divide. Your remainder's going to be your numerator. Your quotient's going to be the whole number. But believe it or not, even though it seems like more work, 15/12, 5th graders, how many 12ths does it take to make one whole?
12.
So I'm going to take that 15/12 and pull out 12/12. That right there is already practicing subtraction. So that's enough for one whole, and that leaves me with 3/12. Do I have enough to pull out another whole?
Yeah. No.
So my answer as a mixed number is 1 and 3/12. And now we're kind of to the point where they need to be able to simplify that 3/12 as well. But I'm not going, Tony, do you know it right off the bat? 3/12? How many numbers would you have to test since the numerator's 3?
He knows how to do it.
Who does?
Cyrus, you can simplify 3/12, right?
Come on, go for it, Cyrus.
It is 1 and 1/4.
Yes.
Good job. Way to go, Cyrus. So despite what y'all think about us and say in your mind while you're doing that new math, we have been teaching them some stuff, and they're learning, guys. They really are. But you saw how simple that was? And with that one, she rolled twice, I rolled twice. We did equivalent fractions, we did adding fractions, we did subtracting fractions, and in this case, we even did improper to mix, and we simplified. That is a lot of practice in one game. So go to Dollar Tree and just,
Well,
you
pull
know,
out the dice from
an old Monopoly game, that's right. If you're like me, your children have destroyed all the pieces anyway, and if you can find 2 dice in a drawer somewhere. All right, so that's that, and if you need, you know, more information, didn't they say they were gonna post this on the website?
Yes, this video will be on the school's
And it's
website.
also on the pamphlet that y'all given.
Yeah, you should have received a pamphlet, I think it's white.
It's called learnzillion.com.
Yeah, this is just additional information. I've had so many parents tell me personally, they were like, I don't know what else to do. I guess I'll get on the internet. I cannot help my child with their math. Well, here you go, learnzillion.com. It has tutorials, which are some quick videos. If you search adding fractions with unlike denominators, subtracting fractions, changing mixed numbers to improper, and they have all that. Additional information and tutorial. But it is it in there?
Yeah, so it's built from next year, and the next year it goes all the way up to high school.
That's right, it goes through high school. So next year, when they're in 6th grade at middle school, go to learnzillion.com. But it is in your pamphlet, it's on,
When you open it up like that, it'll be right here.
yeah, at the very bottom, when you first open. All right, was that it, Ms. Tammy? Okay, and we appreciate y'all so much for coming. It means a lot. Thank you for your patience. If you ever have any questions, just don't hesitate to contact us.